Okay, now we're going to convert decimals, the type that are terminating decimals, to fractions. So the way that we do that is we just put the decimal number over the right power of 10 and reduce it. So let's say we have 6.25. So 6.25, we have two decimal or two digits after the decimal. So those two digits need to have two zeros. So that would be 25 over 100. So I've converted this decimal to a fraction already. It's a mixed fraction, and I could reduce this by dividing the top and the bottom by the same thing. So this is just like dividing by 1. And if I divide top and bottom by 25, I would get 1 over 100 divided by 25 is 4. So I get 6 1/4, which, if you're familiar with money, 6.25 is $6 1/4, and you can see that it matches up with the same fraction. Okay, if I had something with a longer number of decimals, but it did end, so well, you know that pi 3.1415, but it continues on. So let's say we cut off all of those and we just had we truncated it. That's it, just cut them off. And let's say that I just wanted to find out what the fractional equivalent would be of that. Well, this would be 3 and 1,415 over the right number of power of 10. I have 4, so I need 4 zeros. So it would be 1 0 0 0 0, 4 zeros, which is 10,000. So I have 3 and 1,415 10,000s. And I could reduce this probably. I don't know if I want to take the time to do it, but I could divide by 5 and see if I need to divide by more to reduce it further. So that would be the way that you make a decimal into a fraction with terminating decimals. Now, if they are repeating decimals or non-terminating, it means they continue. So, like if we have 0.7 repeating, right? There's two ways that you can do that. It's using the property of 9 patterns. Property of 9 patterns. I'll show you that every time that it's just a single digit repeating, you can put it over 9. So this would be 7/9. And if it was 0.1 repeating, it would be 1/9. And 0.3 repeating, remember that was 1/3, but you could put it over 9, 3/9, which that you can reduce further, right? Divide both by 3, you get 1/3. So you can see that even the 0.3 and the 0.6 also can be reduced, right, to 2/3. So you can use the property of 9s. If it repeats with 2 decimals, so like 0.171717, right? If it repeats like that, so 17 is repeating, then you put both of those digits over 99. So 17/99, and that's how you would use that property. Now, we do have another way of doing it, subtracting equations, and sometimes if it doesn't repeat right off the bat, so maybe you get like 0.166, and the 6 repeats, right? So that you could say, well, it's 0.16 plus 0.006 repeating, and then you can put this part over the 9, but it gets a little bit more confusing to do it that way. So I like to use the subtract equations method, and let's just do the 7/9 first, or 0.7 repeating. So the way I would do that is, so I take this 0.7 equals some number, so I want to find x as a fraction. So the way I do that is subtract equations, and so I multiply this whole equation by 10, just like how before with the terminating decimals I had a power of 10. I do the same thing here, but I multiply this whole equation by 10 because I have one decimal repeating. So I have 10 times x is 10x, and then 10 times 0.7 would be, so I move the decimal place over 1, right? So this would be 7.8 And then now at some point, remember this is a bunch of 7, so the 7 is going to repeat. So I'm just going to move the decimal place over 1 and keep that 7 repeating there. And now I still have this original equation that I can use, which is 0.7 repeating equals x. And then what I do is I do something kind of funny. I'm going to subtract these two equations from each other. So I take this minus this and this minus this. So 10 minus 1x would be 9x's. And 7.7 repeating minus 0.7 repeating. Well, you can see that if I had all these things repeating and had 0.7 and all these things repeating, you can see that when I subtract them, 7 minus 0 is 7, and then 7 minus 7 is 0, 0, 0, and it would just continue. All these would cancel each other out to infinity. So all of these would cancel out with all of these. So this just becomes 7. And then to find out what x is, I just divide both sides by 9. So I get x equals 7/9. Okay, so that's the way you would do that. If I wanted to do 0.17 repeating, now it has two decimals that are repeating, so I multiply by 100. So I get 100x equals, and I move the decimal place over 2. So it's 17.7 repeating. And I subtract the two equations, and I get 99x equals 17. And then I divide both sides by 99, and I get x is 17/99. Now this, if you can master this method, then it helps out a little bit when we encounter these kind of numbers where it's 1.6 repeating, and just the 6 is repeating, not the 1. So it's like 0.166666, and it just continues like that. So this, the way I would manipulate this is it's one number repeating, so I'm just going to multiply by 10. So I get 10x equals 1.6, and then the 6 is repeating, right? And I'm going to subtract this from it. So I get 9x equals, all of these cancel out with all of these, and then I have 1.6 minus 0.1, which is 1.5. Now, I want to have it all whole numbers because that's what a rational number is. A rational number can be expressed as a fraction where they're both integers. So I want to make that an integer. So all I have to do is multiply this whole thing times 10 to move the decimal over one more place. So it makes it 15 equals 90x. Divide both sides by 90, and then I reduce that. So I think 15 actually goes into 90. Well, let me just, I'll divide both by 3, that's a little easier. So 5 and 30, right? Yeah, 90 divided by 3 is 30. Okay, and then divide both of these by 5, and I get 1/6, right? So yeah, that is the fractional form of that decimal. So that's how you convert decimals into fractions. And we've covered how to do terminating decimals. Just put it over a power of 10 that matches. And how to do terminating decimals. You can use these properties of 9, or you can subtract equations. You set it equal to x, and then multiply the whole equation and subtract it from the original equation to get the value of x as a fraction. Okay, so that's it for converting, and we'll see you in the next video.